All right. Welcome to everybody. Thank you for joining our webinar today. My name is Alex Welk. I'm here with Harry Wilson, and we're going to be taking you through our webinar today around predictive maintenance, keeping your HVAC running at peak performance. So by way of quick introductions, I'll introduce myself and I'll turn it over to Harry. I've been in the facility space and the multi-site facility world now for a little over 15 years. So obviously this picture here was the before picture. Now you get the weathered and a little bit grayer version of me. And as for our multi-site operators, I always say that facility years are much like dog years, right? So every 7 years in a fiscal calendar typically passes. But I've worked really across a number of verticals: big box, small box retail, lots of time in C-store, some grocery, as well as lots and lots of restaurant customers, from casual dining to QSR, et cetera. And I've typically worked on the supply side as an integrator, tech-enabled solutions for both preventative and reactive maintenance. What we're going to talk about today really excites me because it's kind of the evolution of my background and how we get cheaper, better, and faster in terms of how we execute against our maintenance budget. So turn it over to Harry to introduce himself as well.
Thanks, Alex, for that. Yeah, pleasure to meet you all who have joined today. I'm Harry Wilson. I'm a senior analyst at the independent market research firm Vedantics. For those who don't know what Vedantics is, we're an independent research house based out of London, as well as a presence in New York and Boston. And we cover sustainable technologies. So within that, I sit within our real estate and built environment practice, and I cover all things to do with energy management and building electrification and energy resilience. A little bit of background about me. I'm a mechanical engineer by trade. Spent a few years in the actual building design industry, designing HVAC systems across EMEA, the US, and APAC. And yeah, very excited to be on here. Thank you, Alex, for having me on, so we can talk about this exciting topic and, like Alex said, the next step in maintenance strategy.
Awesome. So I think from an agenda perspective, just to kind of quick housekeeping, really kind of the goals and kind of the segments we'll take you through here is Harry's going to take us through understanding what predictive maintenance is, particularly in the context of commercial HVAC systems. We're going to talk through the benefits of predictive maintenance and some strategies, right? And then I'm going to come in as well and offer up kind of my take on the role of EMS systems, software-enabled systems, from a monitoring and management of overall system HVAC health. And we'll talk about some implementation strategies and hopefully save a good amount of time for some Q&A and engagement. So, again, I think about, how I've spent my time the last 15 years in this space. And, for any facilities folks and multi-site operators that are involved in taking care of the buildings inside and out, and all of the great associates and consumers that travel through the space day in and day out, I don't need to tell you this job is really hard. This function is really hard, right? There's a lot of manual nature to it. There's so many competing priorities. There's never enough resource. There's never enough budget from a CapEx or OpEx perspective to get the job done, right? It's very difficult. It's very chaotic. Often my customers over the years, right, by the time they sign into their email, which is usually 5:30, 6 a.m., there's already 50 emergencies, right, from the top of the inbox down. Where do I spend my time? What is the best use for my business in terms of how I need to focus my day, how I need to organize my day, how I need to ensure my end customer, as the store managers and the hierarchy of operations and store personnel, are taken care of, right? How do I prioritize my day? And I had a customer that I worked with for a number of years, and they operate an extremely large C-store fleet. I think they're north of these 20,000 locations today, mix of both corporate and owner operator franchise owned. And he hadn't spent quite as much time in the facility space, and he had inherited a pretty senior level role. And one of the things he always characterized the facility function as is absorbing. The way to do it effectively was to absorb all the chaos and find a way to project order. And I helped him a lot in that philosophy and that endeavor. But a lot of it historically was through, grassroots, grunt work, a lot of manual work, a lot of setting up various processes, and obviously over time, like leveraging technology, and people, and best in breed, SOPs, right, to get the job done. I think what we want to talk to you about today is the evolution of foundationally. There's lots of great toolboxes out there for facility folks, for energy management folks, for sustainability folks. But what we want to talk about today is how do we really harness the power of data and technology, both from a hardware and software standpoint, to really gain insights, put digital eyes into all of our store environments, whether you own 20 stores or 20,000 stores, right? And have the ability to understand what's happening in those, look for signals of health, and rather than constantly being on our heels of reacting to the chaos, how do we find ways and methodologies through predictive maintenance, and the leverage data environment, to be able to project a little bit more order. So as you look kind of to the right side, these are some of the things we hope to achieve, and between Harry and myself kind of take you through in a meaningful and thoughtful way today. So with that, I'm going to turn it over to Harry, and he's going to kind of take us through understanding the predictive maintenance in the HVAC environment.
No, thanks, Alex. So I guess the big important question is, for this new evolution in maintenance, how on earth do you define it? What actually is predictive maintenance? And I mean, there's a lot of text on this slide, but we'll go through and we'll unpick it. So predictive maintenance is fundamentally a maintenance approach which leverages predictive data analytics to anticipate and prevent equipment failures before they begin. So this data analytics is really essential to achieve this maintenance approach. You need to be able to have the data for when equipment has failed before and understand the precursors that led to that failure. And then software solutions are able to identify them before failure is even near approaching, and then you can act and conduct remedial action to prevent that failure. So in terms of the technologies that go into it, the technologies including IoT sensors, machine learning, and other advanced analytics really do monitor equipment condition across all of your facilities, whether that be at a single site or across your entire portfolio. And it really monitors it in real time and looks for those failure precursors so that it can forecast future failures. This allows for just-in-time maintenance, i.e., the maintenance activity occurs well before any failure, and it stops you, having that reactionary mindset. The data, that a solution like this needs to aggregate, it says IoT sensors, it really needs to connect to all of your equipment, your HVAC distribution, and many other different elements of the building to really understand, what leads up to a failure, what events happen that may not mean much at the time, but are indicative of a future failure. For multi-site commercial buildings, which, we're framing this definition in the context of it, the key outcomes are really optimized and standardized maintenance efforts. So, whether you've got 20,000 different stores or, 2,000 or even 5, it's all about standardizing across all of your different sites to make sure that you can achieve greater efficiency and cost reductions. So in terms of maintenance approaches, we have what we term a maintenance pyramid, and you have the more basic elements, the basic approaches to maintenance at the bottom, and you have the market leading at the top. So as you can see, predictive slots in just beneath proactive on the maintenance pyramid. As you move up, obviously you need more data to be able to enact complicated and sophisticated approaches to maintenance. So if we start at the bottom where we have reactive, and this is a very common maintenance approach for many people out there, this is very much the standard, a piece of equipment breaks and therefore you react and you fix it. That's the reactive approach. And it really is, a run to failure mentality, i.e. the equipment will run until it's done running and then you replace it or repair it. The step above that in the blue square is preventative. So what this is more taking a planned maintenance approach. Now, this is something we see very common. We see this, in many different sites and facilities. And this is, this equipment has been running for X number of hours, therefore it's time to conduct maintenance. Or, this much air, cubic feet of air has passed through my air handler, therefore it's time to conduct maintenance on it. Now, condition-based maintenance goes one step further. So this might be more about actual rules which apply to the equipment. So if we go back to that air handling unit example, this may well be, the pressure drop over my filter on my air handling unit has reached a certain amount. Therefore, I know it's time to go and change the filter, or clean it even. That's really the condition that then drives the maintenance activity. Now we've got to the top of the pyramids, which is where things get really exciting. So the predictive maintenance element is all about pattern recognition. This is where big data analytics allow for the detection of failure precursors. So when you can understand the events that lead up to a failure, and then this alerts you to that impending failure, and you're able to enact measures to avoid it. So an example of predictive maintenance might be your chiller might have a slightly different acoustic output or a different noise coming out of it that, obviously we can't detect, but an IoT sensor powered by, big data analytics and smart intelligence can really detect that and alert you to, loosening of internal components, different stress on different materials, and really help you stop that failure before it even happens. Now we're at the very top, the proactive element. And this is very much building upon predictive. So proactive is again, it goes that further step one more to use artificial intelligence and machine learning to really change the way your equipment behaves to avoid it ever getting into the situation where failure will occur. This latest step on the pyramid is not quite realized yet, but with the pace predictive solutions are developing at, we'll be there very soon. So if we jump on into, why predictive maintenance is important for commercial HVAC systems, there's really four key reasons why. And the first two are more about the occupant comfort and the indoor environment. So across the US, obviously, as of late, there's been a lot of heat waves and record heat. And it's really important to maintain that operation of cooling equipment to make sure that there's a safe indoor environment for occupants. With regards to safety as well, it's also important to make sure that everyone is well ventilated and that the indoor air quality is of sufficient standard to really make sure that, your tenants and those within your commercial buildings are satisfied. The next two are more related to the equipment itself. So you get extended equipment life. So for example, the equipment obviously can last for longer. There's less unexpected breakdowns. It means if you're regularly maintaining the equipment and keeping it running in peak performance, that means obviously the equipment lifespan can be extended. And the final one is the reduced workload of the facilities manager. So Alex mentioned, how hard this job is and how, solutions are out there to aid you. And really a predictive maintenance approach is not there to replace the role of an FM. A predictive maintenance approach is there to supplement your thinking, your decision-making, and really make sure that you're making the best decisions related to ensuring your facilities are operating at their highest possible standard. It unlocks, maintenance scheduling, automated reporting, and really saves you on that workload area.
Yeah, and I think maintaining the uptime, right? I think, no FMs work harder than when something goes down and there's a 6 or 8 week lead time to replace it, right? So, and that has so many ripple effect implications, right? Of what is the environment like for associates and for end customers. Scary things like OSHA and notice of violations and things like that. They can be entirely avoided by keeping the equipment running, keep the cash registers ringing, right, and also protecting, product and mitigating product loss, et cetera.
Absolutely. It's all of those things that build on and just make it all a lot smoother rather than the added stress of that 6 to 8 week lead time, well in advance of the equipment that may have failed, but you've been able to take the remedial action to stop it in its tracks. And you can then, progress normal business operations, which is really important.
Yeah, there's a facility manager on here somewhere going, how do I get to 6 to 8 week lead time? Because I'm sure with certain equipment, it's much longer these days.
Yeah, no, absolutely. I was going to say, it sounds quite quick then. So if we jump in, what I've prepared on the screen is just to try and talk us through the key components and technologies required for predictive maintenance. So if we look at the actual data side of things, what do we need to do to collect the data, aggregate the data, and then analyze the data? So focusing on collection, as I mentioned in the definition, you need to use technologies like IoT sensors, connected directly to equipment, HVAC equipment. Your utility meters and sub-metering, if available, can all field the analysis, as well as, direct connection to the BMS or BAS. And this is really where it all starts in terms of the collection. It's, you want that real-time data. You need to have the energy consumption data as granular as granular a level as possible. And that really all fuels in and gets aggregated into either a cloud platform or an edge software solution. So, where this data is stored, where it's processed, big data analytics can happen in these form of environments. This then leads on to the analysis, which is where you have certain analytical features like regression modeling, machine learning algorithms, and rules-based engines that really allow, the software to identify trends. It can analyze large data sets for, patterns and interdependencies. And then also, identify, the key characteristics that lead up to failure so that they can be averted in the future. As we move into the right-hand side of this diagram, you've got the functionality side of things. So obviously with all of this data, it makes a lot of sense. And, you've actually got to convey the findings to the user, to, those involved in maintenance. So, you have dashboard interfaces with real-time data visualization that allow you to see how your equipment and facility is currently operating. And also, your performance. If you're aggregating data from your meters, you can see how much energy you're consuming. It's really, that single pane of glass of how things are operating. And this also extends into for alarms and anomaly detection. If something goes ajar or something goes off-piste, you're able to see that and really deal with it in an effective manner. Final step, which is more related to the maintenance, is all about how it can automatically schedule. Predictive maintenance software suite will help you be able to organize maintenance, identify tasks for maintenance, and really manage that maintenance workload. Resource management is the workforce, the maintenance materials, and all sorts.
Yeah, and I think there's,
Oh,
sorry, just to interject real quick, Carrie. I think, there's speed and cost and quality implications of being able to see that sooner, right? With my restaurant customers, it's, without fail, a walk-in cooler, a walk-in freezer, right? Or a single rooftop unit over the back of house kitchen always goes out sometime between 5 p.m. and 7 p.m. on a Friday. It's just a rule of maintenance, right? So, the ability to call these things out sooner, either triage and do some work remotely to see what we can do, potentially avoid rolling a truck, or roll a truck when we know it's going to be business hours, when we know we don't have to open up and pay emergency fees and open up part houses, right, and pay time and a half, or double time on a holiday, right? So
exactly. It's all of that, those clever maintenance functionality that really do make the role of those responsible for maintenance easier. Those are all things that you're actively looking to evolve in, when you're responsible for maintenance. And, with the monitoring and the real-time data visualization that you have, because you've aggregated all of your data from everywhere you can really see that, and, fundamentally make your job easier. I think that's the key takeaway. It's there to support and enhance you in your normal roles and responsibilities. I guess the final thing on this diagram is just the loop back. This is a continuous improvement process. If you follow that feedback loop back, everything that the software is looking for, it knows what to look for in terms of failure precursors. You're able to get reports on the performance of the software and the, averted failures. And it really is just a continuous improvement process. It's all about, that big data analytics and identifying more patterns gets fundamentally better. And it's just the right outcome. If we jump on, we've got a poll now. I'll let you take this one.
Yes. All right. So our very first poll. How far along is your organization in adopting predictive maintenance for HVAC systems? So I'm going to turn it over, and I think Marsh is going to administer kind of a poll, and hopefully we'll get some results here in real time. So it's a pick one as it best represents your organization, and kind of role in the journey. Apparently, the hosts and panelists can't vote, but I have a good sense where we're going to come back here. All right. We got 17% not started yet. We got kind of the what's the famous the snake that ate the rat, so to speak, right? So we've got a couple in the in the middle here, right? So in the planning stages, we're partially implemented, right? This is not straightforward stuff, particularly when you think about the history and evolution of how most companies, even the most sophisticated, Fortune 500 companies here, that are down this journey. So don't see anybody fully implemented. So by judgment of your pyramid and the shape of where that volume falls on your pyramid chart, this seems to check out about right here. So thank you guys for the participation there.
Okay, so back to me now, jumping into some of the benefits of predictive maintenance. We have 4 key benefits. Obviously, there are many benefits to a software solution like this, but I thought it best to summarize it into 4 key categories, as it were. So the first one, obviously, reduced downtime and costly unexpected breakdowns. We've just been speaking about this. You really want to maintain that uptime. You want to avoid unexpected breakdowns and then have to deal with whatever lead time the manufacturers are prompting you with. 6 to 8 weeks is quite optimistic. However, with a software solution like that can deliver predictive maintenance, it means that you're never placed in that situation without knowing, and you're able to manage your maintenance activities a bit better and make sure that everything's done on time. The second one, extended HVAC equipment lifespan. So this is all about prolonging the asset life. We see that HVAC can last 15, 20 years with the proper maintenance. And there's many components within HVAC that could even last further. It's, the mechanical parts, the moving parts are the ones that require the maintenance. Fundamentally, mechanical things do fail. That's very much in their nature. But it's about making sure you catch them before they fail, to extend that life.
And is it fair to say, Harry? I mean, the more they run, right, the more those mechanical parts run, the more wear and tear there is. So, the thoughtfulness and intelligence of when do they need to run, right? Do we need it running in off hours? Do we need it running at the same rate, maybe as we're opening a store or closing a store, right? And all of those little pieces, right, like minutes on your cell phone bill, they add up over time, I think is what I'm hearing.
Exactly. I mean, I remember way back when in college, I majored in mechanical engineering, and one of my professors told me fundamentally everything mechanical without proper care does fail. It's one of those things, especially when you're running it in ways that it does not need to be run. I think you've picked up on a really good point there, Alex, as in there's a lot of things that you can identify in software solutions like this that, speaking about the dashboards and visualization, it's equipment being run in ways it does not need to be run, as in does everything need to be running at 100% when there's no customers in the store?
Sure.
When you just open up, do you need to be running your fresh air volume at the maximum amount? And I
Sure. Or
think,
if we know
yeah,
there's a problem, right? We know there's an inoperable unit, but we're still blowing a fan and we're trying to cool. The supplier isn't getting where we need it, and it's nowhere near the zone temp, and we're blowing hot air, right? We're running those components essentially for no purpose. In fact, the antithesis, actually worse than that, right? We're making it less comfortable. We're
yeah.
doing something less desirable to the store environment while running the parts while consuming energy, right? It's kind of the trifecta of a problem.
Completely. You've hit the nail on the head there. As in, yeah, there's a lot that you can identify. And that adaptive control regime, slightly modifying just how you run your building to get the same outcome can really extend that asset lifespan. I think, building upon that, the next main benefit is, of course, improved energy efficiency, as in the fact of the matter is when equipment starts to degrade, when, failure is coming, there is a drop in performance. We'll unpick this in a couple of slides' time, but the failure precursors is reduced performance before failure because things are loose, things are going wrong. There's problem within the actual equipment itself. And of course, if you improve your energy efficiency by making sure your equipment runs at peak performance, you save money on your utility bill. You're not wasting energy. And that's one of those almost trickle down, positive outcomes of
Absolutely.
enacting predictive maintenance. I guess as well, if anyone out there is pursuing sustainability-based initiatives, or if you're subject to local, state, or federal reporting for carbon emissions, the more energy you save, the better. There's less carbon intensity, less carbon emissions associated with that, all as a byproduct of that improved energy efficiency. The final one, of course, enhanced system reliability, more trust in the system. Maintenance is conducted only when it needs to be. You know that your system is reliable and it will run, and you know that it's being monitored, at the highest possible level. You know that you've got an array of IoT sensors and different data sources to really prove that your system is running as best as it can. And also you're reducing the likelihood of, catastrophic failure.
Awesome.
Awesome. So, as promised, we're now going to jump into some predictive maintenance strategies. But as I mentioned, I promised it was in a couple of slides. Here on this chart, we have equipment performance on the y-axis and time on the x. And what we have in effect is, the performance plotted against time with regards to failure. And, I've put the title here, HVAC equipment gives lots of failure warnings if you know what to look for. And it's really true. So you can see in the green dot, that's when failure is initiated. You can see normal operation, a straight horizontal line before that point. And then as you start getting closer and closer to that ultimate failure event, when equipment performance is 0, you see it slowly starting to curve down. And that's completely because, it does degrade over time. And of course, as you can probably tell by the curve, it degrades a lot quicker the closer to failure it is. So if we jump in, so what I've been able to do is, again, going back to that maintenance pyramid, is I've been able to plot the different maintenance approaches on this chart. So proactive maintenance is measures that you put in before failure event has even been initiated. So you could argue some preventative measures fall in this place here, but it's really more that proactive, trying to enact control changes to make sure that performance remains steady before failure ever happens. You then have the predictive window, which is the second box, the second bound from the left. This is where, equipment performance can be quite normal. You see that line that slowly starts to taper off towards the end of that, that section. But ultimately, you think your equipment is running fine to the naked eye, to your normal maintenance regime. The equipment seems absolutely fine. There's no reported issues from your occupants. It's really business as normal. You then enter the condition-based and preventative regime, which is where performance starts to degrade. So, going back to that air handling unit filter example with the pressure drop, that performance has degraded because the fan is having to work harder to overcome that pressure drop. So you can really see that. And this is where those sorts of interventions and remedial actions are carried out. And then finally, you have reactive. This is where it's obvious that the equipment is close to failure or has failed. And this is where, you need to step in and actually fix it.
We should have done a poll here, Harry. I think we may have seen somewhere between 70 and 95% of folks being detecting it in this last quadrant here.
No, absolutely. And of course, it goes back to, your comments about this is no easy job. When you're managing many different forms of equipment across many different sites, it's quite hard to stay on top of it, before it's very obvious. There's a lot of conflicting priorities and responsibilities. So obviously, I wouldn't be surprised. That's why the pyramid is the pyramid. But if we look, what I plotted here is, just some points and some noticeable things that may prompt maintenance. So you can see if we start, at the change in noise, that's your condition based. That is, you've heard your equipment, you can hear there's an audible problem. That's prompted you to enact maintenance and fix it. Hot to touch is another one. If you can feel an equipment getting warmer than normal, That's very much a clear sign that, something's causing friction inside. Something is doing something it shouldn't be. Therefore, it's time to get in, either change the lubrication or, enact a different strategy. As you get to the reactive, this is where, it's really close to failure. So you can see whether it be, mechanically loose components that are rattling or causing damage to the equipment. And then as soon as you spot ancillary damage, you're very close to failure. If we jump on to the next slide, what I've done now is really try to identify some of the key, predictive tactics and strategies that you can really have to catch, these failure events before they get as bad as, the steps I've just walked through. So a couple we have on screen: ultrasonic testing, vibration analysis, thermal imaging. And that little dot in the middle, that's half yellow, half orange. That was oil analysis, lubrication analysis. I think my little descriptor has been deleted or run away. But if we jump on to the next slide, please. If we unpick some of these strategies, so you can probably tell by these titles, these strategies are quite, analytical, they're quite detailed. And we'll just talk through them one by one to try and give you a flavor of what actually makes up predictive maintenance. So, if we start top left and we do ultrasonic testing, this is, where there is that ultrasonic sensor that really, is put onto a bit of equipment and high frequency sound waves, a bit like a medical ultrasound, can detect the internal shape and, form of equipment and really detect leaks and electrical problems. It sends that sound wave in, it comes back, you can tell, if some of the sound waves are getting out. If we move on to thermal imaging, this method may use infrared cameras to identify hotspots that you can't feel. So how we talked about that hot to touch. Obviously, if it's getting warm right in the middle of your chiller, you'll have no idea. So this can really help you out here and, indicate friction or electrical faults and really get in there and fix it. Vibration analysis, jump into the left-hand side. This is that type of, this can identify abnormalities in machinery vibration. You see this in motor drives and gear drives. It's all about imbalance, misalignment, and wear. The final two, the ones in the blue dash box, these are the ones that are also, strategies that can be conducted in a preventative manner, but in predictive, they use the sensors and they're able to pick up on changes well before failure occurs, rather than them being spot tested in a preventative manner. So acoustic emissions, is your equipment noisier than normal? But also, are there changes in high frequency sound that we can't hear as humans? And this can be materials under stress, cracks could be forming, all sorts of awful things can be happening, letting out a lot of noise that we just can't hear. And then oil analysis, looking at that lubrication, is there contaminants, is there, metal shrapnel within the lubrication, a clear sign that things are loose and falling apart within the equipment.
So time for our second poll here, and I think this is a rating system. If we go back one, thanks, Marsha. What do you see today as the biggest challenge in implementing a predictive maintenance for HVAC programs in your own organizations? Right? Is it initial cost and budgeting, lack of expertise or training, integration with existing systems, data collection analysis? That's a big one, and convincing stakeholders that there's a value there. We'll pause for just a second, let everybody make their rankings. Hear everything from most challenging to not challenging at all on each of these. I think you get one selection. And if you blow up the window, you can kind of see all 5 of the rankings: most challenging, somewhat challenging, neutral, less challenging, and not challenging at all. And we'll give everybody a minute there. I may have lost the window, Marcia, so you'll have to let me know, and maybe you can pop it up there.
Yep, I'll go ahead and put it back on in just a minute. I'm giving everyone just a second since
Perfect.
it's no longer.
Making sure I didn't hit the wrong button here. Okay, let's see what we have. Most challenging, initial cause and budgeting. Okay, so we've got some pretty good, spread here. Integration with existing systems. Kind of a mix there in terms of convincing stakeholders. Cost and budgeting seems to be pretty challenging, and convincing of the value. And the data collection has a big span there as well as lack of expertise and training. Okay, very good.
Yeah, so it looks like initial cost and budgeting and then convincing stakeholders of its values
Yeah,
at the top.
yeah, absolutely. In
Um,
terms of biggest challenges.
Yeah, no, it makes complete sense that, trying to get the initial budget and proving that the budget is worth it. Yeah, it's that major sticking point.
Absolutely. So speaking of challenge, back to my world as I started this call for our facility folks that are on, right? I think this is a reality of flying blind, right? In the world of trying to understand and predict failure if you don't have digitalized and into what's happening in your store environments. And that's really the entire suite and portfolio of equipment, right? An in-store environment, but certainly for HVAC, right? It's typically, depending on the vertical, one of the top 3 trade spends, right? There's long lead times and supply chain issues. But there's typically in the facility manager's world limited visibility to what's happening, right? I mentioned constrained budgets, lack of real data to actually make decisions. Usually it's squeaky wheel gets the oil, right? There's not a set of data from which to base some of this, right? So not sure when the next catastrophe is going to happen. A fire, a flood, a failure of structurally or of a water heater, HVAC unit, et cetera, right? So very limited to that. And it's difficult, right? Let's be honest. Getting here, the reason it's a pyramid is getting here is not easy, right? Getting out of the historical mode of waiting until we can detect it when it actually fails. And it's not just the competing priorities of other HVAC units and other equipment, right? You can see off again. I mentioned the a typical facility manager's inbox at 6:30 a.m. Right? It's invoicing questions, it's staffing situation, it's competing trades, and what's the bigger impact to a store? Is this a high volume store or a low volume store? So there's lots and lots of things that you have to sort through, almost a needle in a haystack, if you will, to understand where do I need to focus my time and effort, and the time and effort of my team. Next slide, please. So, if I think about, an EMS, a software-enabled energy management solution, like GridPoint offers, right? Think about how do we pick apart that problem in the context of HVAC, right? So, we're able to get those digitalized in there, right? And understand what units are operating at optimal performance that maybe we don't have to worry about. What are the things that I probably need to address in the coming, days, maybe weeks before they become a problem? And what are the things that are just entirely inoperable, right? So, the ability to see in and stratify using different sets of criteria, right? Like supply air and zone air, and how long have things been operating out of sync that we would expect to see. And we can actually alert, right? We can pop to the top of the inbox, or provide a notifier. We can customize that as to who it goes to, right? Whether it's HVAC, refrigeration, et cetera. But we want to make sure that we pop the most critical of issues, right? Hey, we've got a door that was left open, right, on the refrigeration side. Or hey, this is back a house, and we haven't been able to reach supply temp for a certain period of time that we define as problematic. We want to provide true, like, real-time health reporting, right, of the systems. So ensuring that, again, we can take a look and stratify. Here's the bucket of assets I need to work on, and here's the priority order in which I need to work on them. And again, this is all through live, intuitive, easy drag and drop, and the ability to visualize these things, in very real time, and understand where the time and the effort is needed, right? And again, we can look at things like connectivity. We can dive down, from the portfolio level all the way down to the individual asset level. There's lots of ways that in stock ways and in both, customized reports where we can, create widgets and dashboards, and we want to see the things that are most important to a particular facility manager. And again, we want to identify these things ahead of time. We want to leverage some of our climate data to understand, hey, there's a minor issue here, and it's not just about detecting and solving it. It often goes to how quickly am I going to be able to resolve it, depending on how quick I'm able to intervene, right? So, and again, back to the problem of the cost associated with it. If it goes down and I've got a supply chain issue, it's going to create continued chaos in that store environment. Probably going to cost me more. I'm going to have to go through some sourcing exercises. There's going to be a lead time. And again, I might go out at a time that's going to cost me a little bit more money had I been able to read into this data and make some informed decisions and maybe roll a truck preemptively. Next slide. So from an implementation standpoint, right, typically we go through a grid point and conduct a very thorough assessment of HVAC assets. A huge value, right? Because I think understanding, I would say 8 out of 10 times we come into an environment and look at a subset of locations, or maybe we go, work on a deal for the entire portfolio. Typically, we're finding somewhere between 15 as much as 30% of the equipment is down and inoperable. And the facility manager probably knows that, right? But having the real-time data to be able to justify, I've got a real problem here where I need some capital or OpEx dollars infused. So we go and we take a very thorough assessment of the assets, and we identify, what's the inoperable equipment? What are the things that, really to come up to par and a clean baseline do we need to address to make sure we have that? From there, we start looking at optimization, right? So, we partner with our customer organizations to ensure we have the right equipment, we have the right package for their needs. If there are any nuances in the space, we want to make sure the placement of thermostats or zone sensors, right, are not right next to the heat vent of a fryer or a heat dissipating piece of equipment. And then we're going to collect the data, and we're going to compare that kind of to our baseline. We're going to look at things like runtime. We're going to overlay set point strategy, and we're going to help our customers come up with what is the right level of comfort, as well as the the right level of efficiency, so we can get some of those hard savings where we're not running the equipment to fail, and we're maybe being very thoughtful about the time in which we run it, what the temps need to be to balance comfort and efficiency, and then how we need to think about how that changes day to day in terms of operating hours, associate hours, customer hours, et cetera. Again, then we kind of get into a stabilization mode, right, where we have very clear processes for managing and monitoring the reporting associated with it. And again, back to training, the ability to essentially understand the why behind why a decision for control strategy is put in place, why we're leveraging technology to help us have digital eyes, right? And then the ability to make that a very living and breathable effort that doesn't happen one time, because as we all know, in multi-site, there's lots of turnover. There's new folks constantly cycling in from the line level all the way through management. So I think, wrap up that, what GridPoint and any great EMS solution delivers is much more than, what we've been talking about here, right? I think we've spent a lot of time talking about enterprise control and visibility, the ability to manage and monitor every energy consuming asset. We can leverage that data. Harry alluded to this a little bit. We can leverage that edge data if there's sustainability goals in terms of carbon footprint reduction and do the calculations there. We are very big into establishing through a handful of clicks the ability to change set point strategy, right? Or to change policy in a certain geography at a certain time of year. You can do it in 2 clicks. Imagine having to do that through the governance of calling operations folks and having them make these changes. You'll never really know, in the output data of what you're measuring and the key performance metrics, if that's truly done or not without the line of sight and visibility. We do participate in demand response programs. We oversee that, right? So if there are certain events in municipalities and utility providers, we have the ability to actually help our customers do the right thing for the grid and generate some incremental revenue in the process. Obviously, a big piece of what we do, and Harry alluded to this as well, is how do we ensure that our solution pays for itself? There's tons and tons of operational benefits, but we, always like to make sure through, historical billing data that we can have the solution pay for itself, right? And simultaneously deliver all this wide set of benefits. Talk a little bit about the administrative burden that we reduce, and certainly the curtailment and avoidance of both gas and electric. And this all enables our ability to lower and mitigate risk, right? Mitigate risk of capital budget overruns, safety risks and violations, OSHA complaints, et cetera, within our customers' organizations. So, a big eye chart here in closing, but, GridPoint is all about providing total line of sight, total digital eyes into a location, right? We start with a free assessment in terms of understanding where you are, what type of equipment you have in there, packaging, and then assessing, what we believe that we can do. What are the goals? There's not a one size fit all approach, right? Everyone wants to save money, but there's also lots of ancillary benefits and the ability to partner with our customers to understand what their goals are, being ESG related, curtailment related, or the operational and CapEx, data benefit as well. So, again, lots of ways to look in at health. We could dissect, and not going to have time to get behind the curtain and show you all this today, but I think, whether it's measuring connectivity, whether it's stratifying what's optimal, suboptimal, and what's entirely inoperable, everything is within a couple clicks, and the ability to dive down from a 20,000 store all the way down to an individual asset. So with that, I think we're ready to open it for Q&A. We greatly appreciate the time. I'm glad that we didn't do any polls on who has the more eloquent accent. Harry, I'd give that to you.
Not too sure about that.
But no, enjoyed the time and enjoyed the audience. And I guess we'll open it up now, Marsha, for anyone that has questions, comments, or anything else they'd like to offer up.
Yes, we do have a couple of questions that came in, and just so everyone knows, you can still submit some questions while we're answering these few. If anybody has any more, just go ahead and put it into the Q&A chat. So the first question that we got was, what are some best practices for training employees when setting up a predictive maintenance type of program?
Yeah, sure. I mean, I think I kind of alluded to this. I think understanding the why, right? I mean, I think any change management effort really starts with how do humans in general think about change, and typically most people think about change as loss, not substitution, or not what they're gaining, but what are they losing. And so I think a big part of the training is the why, all the way down to the site level, and understanding, look, there's still some latitude for you to have control, right? Maybe during a really hot day you have the ability to go and override a temperature by 3 or 4 degrees, let's say. But what we're not going to do is provide the ability to drop it to 58 degrees and leave it there and freeze the condensers, right? So I think it's the why behind, why is the business doing and investing in this strategy? What benefit does that have to the overall business entity? And then how does that trickle down? How can we, save 15-20% on our utility spend and reinvest that in the team, put that back into the capital budget, find smarter ways to invest in the brand and the brand experience for our customers.
Great. Next question that came in. Can you share some real world examples where predictive maintenance has helped reduce an operational cost or extended the life cycle of HVAC equipment?
I can take this one, Alex. Sorry, my internet cut out for a minute or two earlier. But yeah, back for this one. In terms of real world examples, I think it's quite easy to envision them in terms of, when you think about HVAC equipment, the types I've come across, and I'm sure Alex, you can, help with some of these, is very much about, whether you've got your boilers, your heat pumps, or your chillers, and your air handling units. It's all about how it can detect, pre-failure events. If you've got a loose fan in your air handling unit, being able to detect that by reduced performance, reduced airflow, You know, when you can monitor that ultrasonically or acoustically and really identify that movement in moving parts that is not meant to be there, that's what's really unlocked greater value. The case studies that we've come across have really been all about the value is not just in the maintenance alone. It's all about, like Alex spoke through on those really in-depth slides, about what a solution like GridPoints can deliver. It's about going beyond the pure maintenance cost saving and really diving into, you know, those operational efficiencies, energy savings, you know, the freeing up of resource, allowing the FM to prioritize other tasks. So
Yeah.
those have been the key, you know, pretty much preferential outcomes, I'd say.
Yeah, I could, staying fairly high level, you know, we have a customer that operates, you know, very large, you know, convenience and you know, drugstore business, and part of that are prescriptions, right? And some of what we do from a refrigeration standpoint on the other side of the house, right, has to do with monitoring and alerting around changes in temperatures. And so, you know, while full respect to our, you know, restaurant customers and restaurant facility folks that have tens of thousands of dollars of you know, of perishable food, right, that could be at risk. One of our drugstore clients, you know, has very temperature controlled prescription medication, and you know, if they are to lose one of those, it is a pretty significant, you know, on the order of, you know, could be hundreds of thousands of dollars and up every time that happens, right? So, you know, the ability to avoid one of those a year, it you know, more than pays for itself. So there are some outlier you know, defense that we play with our solution, that more than, you know, pays for itself, and the ability to be predictive in addressing issues before you know, there's a kind of catastrophic financial result.
All right, we have two questions left. The next one is, what emerging technologies do you see really shaping the future of this market?
Yeah, I think if we go back to, you know, the pyramids and we see that proactive maintenance, I think the reason that this market is quite exciting is because it can only get better with time. As in, you know, we look at the big data analytics, the more data that you're able to give a solution, the more conclusions it can draw from that, and the better it gets, you know, the better its predictions become. I think that's where the true value is. In terms of what that actually means for the solution, it might mean that, you know, solutions are used to dealing with certain types of equipment. They don't need to monitor a building beforehand, you know, for a certain amount of time to understand how it normally operates. You could have rapid deployment of solutions, and really deliver that predictive value instantaneously. I think the proactive maintenance, we're getting to that. And obviously that comes with more data, I'd say.
All right, we did have one more come in after that, so now we have two left. What are, based on some of the challenges that you discussed earlier, what are some of the key challenges associated with implementing predictive maintenance, and how can they be mitigated?
Yeah, I mean, I think a commitment on the business case, right? And often that comes from the anecdotes and stories like Harry was telling of, like, you know, similar situations, and you know, what was done, what did that investment look like? What did it yield? How was it measured? So I think some, you know, fairly reasonable approximations in terms of business vertical to help make that case study. I mean, I think from the poll, right, I think we saw that, you know, lack data, but then, you know, the ability to get buy-in, right? I think is a big piece of it. So understanding, you know, what the net effect can be, and being able to articulate that to at least get some kind of proof of concept stood up in, you know, a subset of a portfolio, a certain geography, a certain trade, et cetera.
Great. Okay. And the last question that we have, given the high variability in occupancy and usage patterns in fitness centers, how can predictive maintenance for HVAC systems be leveraged to optimize both energy management and equipment lifespan? Specifically, how does the system adjust to fluctuating load conditions in real time? And what impact did this have on overall energy efficiency and cost savings? Let me know if you want me to repeat any of that. That was a good long one.
I think I can start this answer off if you want,
Sure.
Alex. I think, a fitness center is, very fresh air ventilated. You've got very large airflow rates in order to deal with, the latent load of those exercising within. I think when you utilize a predictive maintenance energy management solution, the question was asking about optimized energy management, so energy consumption and also equipment lifespan. So in terms of optimized energy consumption, it's, making sure you're not running that equipment at maximum speed, maximum airflow at all times if it's not needed. You're aggregating all of this data from your equipment, IoT sensors, your environment, whether or not you have carbon dioxide sensors within the actual space to detect occupancy. That's a great way to figure out, just how many people are in the space and adjust your airflow accordingly. And the equipment lifespan section, bringing it back to more the predictive maintenance, you've got.
Not sure we may have,
Yep, I think we lost Harry there.
Harry, we may have lost you.
Okay, Alex, anything you want to go ahead and add on to that?
Yeah, no, I mean, I think I don't know if these are 24, I don't know if these are 24/7, locations, but understanding, foot traffic, by certain times. I mean, certainly there are some 24/7 locations. We would still think about, intelligent setback and recovery strategies, right, for lower time volumes. So I think there's some things that can be done. It's obviously not classic retail, but I will tell you, there are a lot of niche verticals we work in. Movie theaters come to mind, right, where we've built pretty customized solutions relative to kind of the many hours of business, if you will, of show times, and how do we intake their show times and think about set point strategy relative to foot traffic and volume in the space, and what that does to the to the environment. So sorry, it looks like Harry, you're back. So sorry, I didn't mean to.
Sorry, internet
I
must
was
be
filling in for your internet connection. So
no, thank you very much. Yeah, no, it's struggling to get across the pond. But yeah, no, just to end on that, it's a solution that can do predictive maintenance and energy management unlocks both the outcomes of energy efficiency and cost saving, both from averted reactive maintenance and energy reduction.
Okay, and that is all the questions that we have. Just letting everybody know that we will go ahead and send out the recording of this webinar. Alex and Harry, both thank you so much. Any other closing remarks or anything else you want to add?
no, thank you for sticking out. I appreciate everybody's engagement. Great questions. We appreciate the time, and we look forward to hopefully talking to many of you down the road.
Just to echo Alex's comments, thank you very much, everyone, for attending. I hope you enjoyed it. And yeah, thanks, Alex, for having me. It's been great fun.
Likewise. Thanks for joining, Harry. Pleasure.